Welcome back. In this task, we will see how to organize instructions and create a function. We will also see how to use the function that we write. A function has four parts: a function name, the keyword function, arguments, and a function body. We define a function using the keyword function. To the function, we provide data that it operates on using instructions. The data is provided within parentheses that follow the keyword function. The data elements that we provide to the function are referred to as arguments. We can provide 0 or more arguments to a function. If there's more than one argument, we separate them using comma. In this particular example, the function is being provided 3 arguments: hour, min, and seconds. The function body comprises the instructions that act on the data, and we specify the instructions within these two curly braces, open curly brace and closed curly brace. And we name the function using the assignment operator. Note that the arguments here are numbers, but they can be character, data type also. They can be vectors or lists, and they can even be other functions. We will see several examples of functions in which we specify arguments which are functions, and we will see that in the next guided project. Let's switch to RStudio Cloud, where we will write this function and use it. So let me switch the display mode. We are in the same project, PHP Programming Foundations, that we copied earlier. And here is the code for this task. We've defined the function compute num_sec. Let me create some space. We've defined the function compute num_sec exactly like it was on the slide. The only difference is that the arguments are written out on different lines. It's a bit convenient, and we'll see why shortly. And then we have these instructions. And I have also provided some comments to describe the instructions. Let's compare this with the instructions we wrote earlier. So we assigned these data points, the number of hours, min, and sec that we used computing resources for. And then we created these two variables, and then we computed the number of seconds. Here, we just define the minutes per hour and sec per min. We don't define the hour, min, and second that we use the computing resources for, because they get provided using these arguments. And we actually use those values in these instructions. So when converting from hour to sec, we actually use the hour data that's passed in here. Similarly, for min to sec, we use the minutes data that we get passed in. And when computing the total sec, the sec is these seconds. Now, it's quite possible for a function to use variables defined outside the function. In this case, we are not doing so. Notice this instruction, return total sec. Why do we need that? We need that return instruction because when we use a function, we need to get the total number of seconds. And the way we get the total number of seconds from the function is through this return instruction. and we will see how to obtain that value from the function. The function returns it using this instruction, but we have to be able to retrieve it as well, and I'll show you how to retrieve it. Now, to use a function, it has to be available to us, and for it to be available to us, we have to execute it like we execute instructions. So let's do that. I'll press Control Enter, and the function got executed. We can see it here. So we have the function available to us now. Now let's see how we will use the function. So we have created the data points here. So we have defined 3 variables. The first variable, user1hour, holds the number of hours. User1min holds the number of minutes, and user1sec holds the number of seconds that we use the computing resources for. And now, to use the function, we specify the name of the function, compute numsec, and then we give it the data that we just defined: user1hour, user1min, and user1sec. And we say that we are calling the function, or we are invoking the function. And when we invoke the function with these 3 data points, user1hour gets matched with hour, user1min gets matched with min, and user1sec gets matched with sec. That's how the function receives the data points to do the computation. And this is known as argument matching by possession. And the return value we extract using this assignment operator, and we assign it to a variable user1 total sec. So let's execute this instruction to see what we get. So let's define the data points first, and you can watch the console. And now we are invoking the function and saving the return value in this variable user1 total sec, and let's print the value. And as you can see, it is 7812 like before. Now let's say we have another user who has used computing resources for 3 hours, 5 minutes, and 14 seconds. Let's compute the number of seconds for this user. Again, we'll do the same procedure. We create the data points, and then we invoke the function. And we invoke the function by giving it the 3 data points: user2hour, user2min, and user2sec. And we execute it, and we print the return value, and it's 11134. Neat, isn't it? We reuse the code to compute the number of seconds for user 2 without having to rewrite the code. That's the magic of functions. That's the benefit of functions. Now, let's say we have a user who has used computing resources for less than an hour, just 52 minutes and 3 seconds. So how do we use a function that needs 3 arguments, but we have only 2 data points? Let's see what happens. So we execute these data. We create those 2 variables with the data points minutes and second. And since we don't have hour, we call the function without specifying the hour. And so what happens is user3min gets matched with hour, user3sec will get matched with minutes. So the function will not get the 3rd argument. And let's see what happens. And like we expected, we got an error. It says error in compute numsec, user3min, user3sec. It says there's an error in this function called compute numsec, user3min, user3sec. And it says argument sec is missing, that's because it's matching my position. Since it didn't get the third argument, and the third argument was SEC, it thinks it hasn't got the third argument SEC. And it says there's no default for it as well. And we'll see what that means shortly. To overcome this problem, let's define a dummy variable user3hour and we assign 0 to it. Let's execute, and now we execute the function with 3 arguments, and we know that user3hour is 0. And we got a response, and this time there was no problem. However, this is not neat really, right? It'd be good if we can write a function to which we can say what arguments we're passing it and what arguments it's not getting. And in case it doesn't get an argument, the function should be smart enough to use some default values. So let's define a function like that. Here's a function smart compute numsec, and again it has 3 arguments, hour, min, and sec. This small change, instead of just specifying hour, we say r equal to 0, min equal to 0, and sec equal to 0. By doing so, we are specifying default values for those variables, for those arguments rather. The rest of the instructions are the same. Let's see how we would use such a function. We would first make sure that the function is available to us, and we do so by running Control Enter here. Now, we have a user who has used computing resources for 10 minutes and 12 seconds. So let's create those variables. And now let's see how we invoke the function. We name the function smart compute numsec, and then we specify the arguments using these argument names. We say min equal to user for min and sec equal to user for sec. So we are actually telling the function that we are giving it only 2 arguments. So this is known as argument matching by name. And when we do so, we are explicitly telling it that we are not giving it the hour data. And in that case, it will use the default value of 0 for hours without us having to create a dummy variable. So let's execute this instruction. And it worked this time. It didn't give any error. So we have seen 2 ways of defining arguments. The first way we saw the argument matching was done by position. And when we use the smart compute numsec, we specified arguments using names. In fact, we can use the smart compute numsec function to use arguments by position. Let me show you how. So I have keyed in some instructions. We have user 5 who has used computing resources for 1 hour, 10 minutes, and 12 seconds. And let's use the smart compute numsec function, and this time we just specify the data points without naming them. Now, since we have specified all 3, the smart compute numsec function is smart enough to know that it doesn't have to use default values. So let's try it out. We define the data points, and now we invoke the function. And it didn't give any error, and we got the result, 4212. In the next guided project, we will see functions that accept arguments both by position as well as by name. Some of the arguments are matched by position and some of the arguments are matched by names. I hope this gives you a sense of how useful functions are. In the next guided project, we will write our app mainly using a lot of functions written by other users. Functions written by other users can be used by using packages. We will also learn about packages in the next guided project. So in this task, we learned about functions. In the next task, we will learn about vectors and lists. So I'll see you in a short while.